Okay, so what you're looking at here is the thermocouple wire that comes straight off the spool. Looks just like that. It's actually two wires inside of a sleeve, and all you do is you cut the ends, kind of like what you see here, and instead of pointing them off to the meter probes, you just twist them together, and you end up with something that essentially looks like this. If I can get it to focus here. There we go. And how it works is you basically have two dissimilar metals, and when exposed to a heat source, they produce a very small amount of voltage. And lots of different types of thermocouples. This is what's known as a K-type thermocouple. So you can go to Google and type in K-type thermocouple, millivolt to temperature conversion chart, and you should get a ton of results, and they should basically all be exactly the same. So after you make your twists, you take it, you stick it in the in ice water, like right on top of that ice cube there, and it should read 0. If it doesn't, you can fiddle with it, you can mess with it, you can just cut it off and do it over again, whatever you need to do. But I always try to get them to read 0. Gives me a nice solid baseline. And if it doesn't read 0, there are charts that will allow you to add 10 degrees or 20 degrees or however off it is. But I always try to make mine read 0 because I can. I'm not on the clock here, so I have time. So basically, all I'm going to do is I'm going to put the camera down for a second, put about 3 or 4 drops of e-liquid in this 1.8 ohm dripping atomizer here. It's just a little Smoke Tech Octopus. It does have a modified air hole. I don't know how well you're going to be able to see that, though. It's a bigger air hole, lots of airflow, and this thing actually, even though it's hooked up to a little Ego battery, does make quite a bit of vapor. So I'm going to go ahead and just put the camera down for a second and put some e-liquid in it. Okay, and we're ready. So that's the meter over here, and as you can see, it's reading 0. So I'm going to go ahead and hit it. Okay, so I'm concentrating more on the device over here than I am the meter, so I can't tell you exactly, but it looked like I saw about 0.7 or so millivolts, of course. What exactly that translates into, I couldn't tell you off the top of my head, but I'll post a link to the chart, and you can go ahead and look it up for yourself. It's pretty straightforward. See you later.